Till our previous video, we saw about joins in Apache Spark, where we discussed detail in sort merge join. We saw the sort merge join with the help of two tables, where we took customer ID as our joining key. We discussed this in the phase manner, how the partition will behave inside the executor and why shuffling is required. We also see why sorting is required and how sorting will help us to get the perfect match after our join perform. In continuation to that, next video. Hello to world, welcome back to another video. So in this video, we are going to discuss about the Sql HashJoin, which we have seen the strategy of the join. Okay, for this joining purpose, I am going to take these two table again. Okay, I will copy them and let's learn about the Sql HashJoin today. So let's say you are having the two table and we want to do a shuffle HashJoin into it. What happens is first step. Let's do it in phases. So as the first step, what it is going to do, it is going to repartition it. Partitioning will be done here. Okay, repartition. And after the repartition, what will happen is it is going to use a hash function inside it. Okay, let me explain you one by one. A hash function will be applied. Okay, hash function will be applied. So what the use of this hash function is, whenever you input any value to it, right? Whenever you add any value to it, it is going to result the same kind of value each time. Let's say, for example, if you are sending this value over here, the 2 is present over here, right? So if you send this 2 to this hash function, right? Let me change the color of this. Okay, let me keep it as orange. No, red is better. So let's say I'm sending the value as 2 into my hash function, right? It is going to give me a output some value. Definitely some value will be given to me. And let's say let take it as any arbitrary value right now. Let's say x1 and 8 ub. Okay. So this is the hash value of this 2. Okay. The same thing will be done for my other table as well. That is customer ID 2542. So the same hash function, when 2 will come into the picture, right? 2 is here. So when 2 will come into this hash, it is going to result in the same kind of hash function, hash value. Okay. So the use of this joining is based on this hash function. Now the hash value has been created, right? So now what Spark will do? No, the Spark will keep all these similar kind of hash values into one partition. That is its work. Okay. So this is my phase 1. So keep this whole thing into the phase 1. This whole thing will come into my phase 1. Okay. After this has been achieved, what it is going to do, that's the important point now. What it is going to do is it is going to create a hash table for us. Okay. It is going to create a hash table for us. Hash table. Since all the keys has been hashed. Okay. So why it has taken only customer ID? Because these are our joining keys. Whatever you take in your table as a joining key in both the tables, right? That column is going to take as a hash value and it is going to convert it a hash value and it is going to create a hash table. But the question arises, where this hash table will reside? This is the flipping, like I can say a flipping point. Okay. So what it is going to do is it is going to create this inside a RAM. That is why it is a bit faster. Okay. So it is going to put it inside a RAM. So RAM is the place where it is going to hold it. So the question arises, okay, is this the thing it is going to inside? What if the data is very large and it can't fit inside our RAM? So here is the clue. What happens is when this repartitioning is done and all the same kind of, all that record with the identical joining key from both the table end up exactly to the same executor and the partition, it is going to see, okay, now which data frame and which partition is smaller. So whichever will be the smaller one, this work will be done by Spark itself. Okay, you don't have to do it. So whichever will be the smaller partition, hash table is going to get created for that. That's it. That's the whole concept behind it. And please keep this as in your note as well. This is the interview point of question as well. Definitely they are going to ask you how hash join is different from shuffle short merge join. Okay, this is the difference. A small partition will get inside the RAM and a hash table will be created. Now the third thing, what happened at the end? So Spark is going to, stream the large data set to this hash table so that one-to-one joining can be done. And while joining it as well, right, it is going to take the hash values, that is these values. Okay, hash values. So whenever there is a hash, keep this in mind. Wherever there you are performing any hash operation basically, and you are looking the value, right? So it is going to be the complexity of O1. That is why it is so fast. Complexity of big O of 1, linear time. Isn't it very amazing? Isn't it? So what we have done here, if you observe the whole pattern, we did a repartition, we did a hash, we created a hash table, and then we streamed the larger data set to this hash table, correct? So we didn't do any sorting. One operation is directly cut down. That is where the difference lies in our sort merge join and our hash join. There is no sorting in hash join. Sorting operation has been eliminated completely. Okay, that is the major thing here. Okay, so let's go to the practical demonstration for the same. So I'm inside my notebook which we have created, and this is the same notebook, basically our learning notebook. Initially we started with our partitioning. Let me collapse this. Till now we have done transformations, we have done repartitioning and collace. We also have we were in the sort merge join. So today our work is to do something with hash, right? We have to do something with hash. So let me put down the markdown. By the time you might be knowing how to do a markdown, right? Let me make it a big so that it will be very clearly visible to you guys as well. Okay, so %md, and I am going to mark it as my hash join. Okay, well, adding one, control enter in Windows and command enter in Mac. Okay, so first of all, I want to get some, I will take some libraries. So libraries will be from the from my initial setup itself. So we have these libraries, right? Same way we are going to import something new today. So first of all, I want the Spark session. Even that is not required. I directly need from Pyspark dot. But I need SQL dot functions. I need import. I want to generate a data set, right? I want to generate a data set. So a random is a library I want to import, and expression. Okay, these two I will import. So first of all, I want to generate, a kind of what I can say. I want to generate a data set for me, a dummy data set basically, correct? So for that, what I can do, I will create a dummy data set. Okay, no Pyspark SQL from Pyspark.sql functions. It is not function, it is functions, man. That's why I was thinking why it is, it is functions. So first of all, I want to generate a data frame. Okay, so for that, what I can do, I will write it as a data frame customer, customer is equal to, what I will say spark dot range. Let's create 100 records. That will be more than enough. Or let's do 1000, because we need to do HashJoin, right? We need some big data and a smaller data set as well, definitely, right? So let's create 1000. Okay, and then what I will do, with column rename, I will use this. Okay, and I will make this as ID, and I will make it as customer ID, customer customer ID. Okay, and by the way, the dummy dataset which we are creating, you can also load the file. Okay, I have already told you how to load the file, so you can go in that way as well. But right now we will go in this way. Okay, and with column column. Okay, what I need basically the customer name. Okay, I need customer name. For this, and for that, what I will use expr for this expression. In this expression, I want to concat. This is a similar way how we have created back in our sort merge join as well. So I want to concat the customers, customer, and I will concat this with my customer ID. That is my customer ID. This ID, customer ID, with thousands of the values. Okay, we have created the data frame. Now let's do the order data frame as well. So by the way, these all the codes which we use, right? You will get into your my GitHub, so you can just copy paste it from there. No need to type it, because we are not here to learn the coding. We are here to learn the topic, so we have to do it very fast, correct? So order this data frame, take it as it is, then go to my shuffle join. Now the joining has to be performed, correct? So df underscore join. Now what I will do is equal df underscore customer. I have to join this, and currently I will give it a hint. Okay, since it is you have seen it, it was giving me a hint of merge, but we have to use a shuffle hash here. SHUFFLEHASH. Okay, shuffle hash dot join. Okay, now what I want to join? I want to join my data frame of orders data frame. I want to join on my like what is my key. So I want to join in customer ID, right? Is equal to my customer ID. I want to join it on customer ID, and how the join will be performed. Like it will be inner, outer. So I want to do it a inner join. Okay. I want to do it a inner join. That's it. So after that, what I will do? I will do a display of this DISCLA displays df underscore join. Okay. Let me run it. Let's see if it is going to join the values for us, and it has done it. And here is the joining result for us. But we are not interested in the join result, right? We know it is going to get joined. We are interested in how it has been done. So again, df underscore join dot explain explain. We want to see the physical plan for it, how it has been executed, or even if it has been executed with the hash join or not. So that is our perspective to do it. Okay. So coming to the very below, photon range, you can ignore this right now. Photon is the accelerator. I have already told you. So initial plan was executed. Photon shuffle hash join has been performed based on the customer ID. It has created customer ID, how it has done inner and built left. Basically, the left data set was created. Left data set was kept as a hash table. So what was the left? Left was my customer. This is my left. This is my right. Okay. So df.customer was kept as a smaller. It was taken as a smaller data set. Why? Because we have taken the range from around 1,000 record here, around 5,000 record here. Okay. From in yes. So this is how it has joined. It has kept this as a large data set. So this is how shuffle hash join work. So in this series, we are left with a last and very important join. That is our broadcast join. And by default, just for your information, by default, broadcast join is the one join which is activated in our Spark ecosystem. Okay, and there is one keyword for this where we need to disable it before we perform any such join. So this was the whole video about today's join, and hopefully I have cleared your doubt over the shuffle hash join and how it works, and how data frame are selected to keep it in a RAM, and how it performs, how it creates the hash values, how repartitioning is done. If there is any doubt, you can comment down to me. And if you have liked the video, please do like, share, subscribe the video, and let me know your thought over the next video. Okay. Thank you for this.